recording, and I will put up my presentation up today. Okay, now let's get started. Again, welcome everyone to our first seminar series of Next Gen Health Research Bridge. I'm going to be in charge of today's session about directed acyclic graphs in R. My name is Kenta. I am an epidemiologist in population health and health inequalities. The session is planned to approximately 45 minutes. And first of all, I'm going to go over the introduction of the DAGs. Why do we use DAGs in epidemiological research? And I will quickly go through some of the key terms in DAGs and also epidemiology. But the majority of the times, I will spare it to show my R code to develop DAGs that has been used in actual study that has been published with my colleagues last year. Then at the end of the session, we have time for questions and discussion. So if you have anything, please write to the chat or questions functions in the Zoom link. And Joseph can take care of that. Okay, so first of all, why do we use DAGs in our epidemiological research? Because DAGs can help us make causal assumptions explicit, identify confounders, decide what to and what not to adjust for, and communicate analysis decisions transparently between your co-authors, collaborators, and also reviewers. Now I will go through each of the key terms. First one is confounder. Confounder is something that is a common cause of two variables, in this case, exposure and outcome. And therefore, you see the two arrows pointing into exposure and outcome from confounder. And the second one is mediator. That is something that lies on the causal pathway between exposure and outcome. And the third one is collider. That is a common effect of two variables. In this case, exposure and outcomes. And you see the two arrows are collided at the collider variable. And finally, we have effect modifier. That is something that may modify the effect of exposure on outcome. But standard DAGs usually do not encode effect modification. And more advanced DAGs are proposed to encode effect modification and interaction. Unfortunately, we are not able to cover this today's session, but if you're interested in, please refer to this citation. And also, we may cover that in the future sessions. And the standard adjustment rules when our aim is to estimate the total effect of exposure on outcome is to adjust confounders and avoid adjusting mediators and avoid adjusting or conditioning on colliders. Why or why not? We will look at each of the examples briefly. Why do we adjust for confounders? Let's think about the example of coffee drinking and lung cancer. And let's say that we are not familiar with any subjective background about lung cancer. And when we are given such data, we may find a significant association between these two variables, especially coffee drinking. More coffee drinking may be associated with increased risk of lung cancer. However, that may be confounded by the third variable, such as smoking, because smokers may be more likely to drink coffee to a larger extent compared to non-smokers. And therefore, the association that we see between coffee drinking and lung cancer is actually via this third variable, smoking. And it is connected via backdoor paths, which is the terminology used in the DAGs. And we want to adjust for smoking to block this backdoor path. And once it is done, we may most likely to see the absence of association between these two variables. The next, why do we not want to adjust for mediators? We will think about the example of physical activity and depressive symptoms. We think that physical activity may increase or decrease depressive symptoms through a number of mechanisms. And we are also given the data about sleep quality. And if we did not have good subjective expertise how sleep quality is associated with physical activity and depressive symptoms, we may end up adjusting for this third variable to estimate the effect of physical activity on depressive symptoms. If we do so, we may end up blocking part of the path from physical activity and depressive symptoms. In turn, we may end up underestimating the total effect of physical activity on depressive symptoms. And that's not what we want to do when our aim is to estimate the total effect of physical activity on depressive symptoms. Okay, at last, we will look at the example of collider. Let's say we have the data of physical activity and diet quality. And since they are both behavioral factors, they're not causally associated to one another, we suppose. However, our data was conditioned on study individuals with high BMI. We may end up finding the significant association between physical activity and diet quality by conditioning on BMI, a collider in this particular case. And therefore, we do not want to adjust for collider. And those were the standard rules that we want to remember when we make the analysis decisions. Okay, now let's start building a DAG by using a simple study example. Briefly, if I introduce this study, it is cross-sectional survey-based study conducted in Japan among workers at small or medium-sized enterprises. And the researchers were particularly interested in workplace physical and social factors on low back pain. In terms of background and hypothesis, they were interested in investigating whether high physical load at work, such as heavy lifting at work, was associated with increased risk of low back pain. In addition to that, they were interested in investigating whether good interpersonal relations at work may mitigate the association between high physical load at work and increased risk of low back pain. And previous studies have investigated similar research questions by accounting for numerous biopsychosocial factors on low back pain, but they were not really considering causal structure. So the researchers here wanted to develop their analysis or model carefully by accounting for causal structure of each of the variables. The variables that have been included in the study was physical load at work, which was binary exposure variable, and low back pain as a binary outcome variable. They also had a number of covariates, which could be either confounders, mediators, or effect modifiers. Okay, now I will show you how the DAGs can be created in R. We will use the package called ggDAG, which is one of the user-friendly and intuitive package to draw DAGs in R. We will first start with exposure and outcome, and with ggDAG, there are mainly two steps to draw DAGs. First step is to position your variables at XY coordinates. So we have physical load at work as P load and low back pain as LBP. And we will place them at reasonable positions in terms of XY coordinates. For example, P load at 1 on the x-axis and LBP at 3 on the y-axis. And since we want them to be placed on the same horizontal level, we will place them at the same y-axis. The second step is to define causal structure. To do that, we will use DAGify function. We will store this DAGify object as G1, and we will write LBP tilde P load, which is the same way to write code of regression, such as linear regression or GLM. Then we plug in the coordinates that we have defined earlier, label each of the variables. It is optional, but I recommend it so that it will be better visualization once we plot this DAG. And finally, we define which one is exposure and which one is your outcome. Then we can plot it with this ggdag function. G1, the DAG object that we have created. Text equal false argument is to hide the variable name, such as pload and LBP, but instead show the labels that we have defined. Okay, now let's add more variables. We will now add socio-demographic factors. In addition to exposure and outcome, as a first step, we will place age, gender, education, and income at reasonable XY coordinates. After that, we will define causal structures with DAGify function as we did, but this time we will store this as G2 DAG object. So LBP tilde P load plus age plus gender plus education plus income, because we believed that they were one of the causal components that may affect low back pain. And we will do the same for exposure and also the rest of covariates. Plug in the coordinates that we have defined earlier, label each of the variables, and define exposure and outcome at the end. And once we plot it, now we get more DAG-like figure. And at this stage, it is still possible to visually assess which one may be confounder and which one may not be confounder. For example, when we look at the variable education, we will see the two arrows pointing into both exposure and outcome. On the other hand, income, we don't see the arrows from income to physical load at work, and therefore we may end up adjusting for education as potential confounder, but may not for income. And the important point here is, first, it's always good to start your DAG with pen and paper since it's more flexible. And later you can draw DAGs using software such as Dagiti or this ggdag package in R, and then share that with your collaborators, co-authors, and also supervisors. And another important point is that we always draw DAGs based on our subjective expertise. So we define this causal structure position for better visualization and direction of the arrows. And it is always good to continue elaborating on DAGs through discussions with your peers, with your supervisors or experts from multidisciplinary fields. Okay, now we add even more variables, lifestyle factors, in addition to socio-demographic factors. We will add drinking, smoking, sleep, quality, and physical activity status. We will place them at the reasonable XY coordinates. And after that, we will define causal structure. Similar to the G2, we believed that all the variables may be one of the causal components of low back pain, and therefore LBP tilde and all the variables were added with plus sign. And we'll do the same for the rest of the covariates. Plug in the coordinates that we have defined and label each of the variables. And finally, we define which one is exposure and outcome, and we can plot it. Now we get even more complicated DAGs, and it is still possible to visually assess which one may be confounder and may not be confounder. But in this ggDAG package, there is a function to identify minimum adjustment set of covariates to estimate the effect of your exposure of interest on outcome. So we will look at that in the next DAG. Okay, so lastly, we will add all the remaining variables, which are BMI, job satisfaction, depressive symptoms, and interpersonal stress at work. We will place all these variables at reasonable XY coordinates, and we define causal structures for all the variables. We plug in the coordinates that we have defined at the first step, label each of the variable, and define which one is exposure and outcome. Let's look at this G4 object, and we see even more complicated DAGs now, and it is quite effective to distinguish between confounders and especially mediators. For example, by looking at this DAGs that we created, we may not want to adjust for depression and job satisfaction because they are rather seemingly mediators that lie on the causal pathway between physical load at work and LB pain. And interpersonal stress at work, which is something that the researchers were interested in investigating as an effect modification. And as I've said earlier, there is no standard way to add effect modifier in the DAGs, but I just put that for the presentation purpose. But we can cover that in the future sessions, how to model or how to draw effect modification in more advanced DAGs. Okay, now let's see which variables we should adjust for to estimate the total effect of physical load at work on low back pain. To do that, we can use this function, ggDAG adjustment set. G4, which is the DAG object, and the rest are the same. And it will navigate us to adjust for only education, age, and gender, because those were the only confounders based on the criteria of confounders, and backdoor paths will be sufficiently blocked by adjusting for these covariates to estimate the effect of exposure on outcome. It is very common to see a number of epidemiological research to adjust for all of these variables within this research field, and also in the other population health research field. Without causal structure, many people end up adjusting for just as many as variables. So it's always good practice to draw DAGs and then visualize your causal structure based on subjective expertise and identify the minimum adjustment sets of covariates. But this is not the end. We still have something that we need to consider, which is unmeasured variables. In epidemiological research, we always have residual confounding, and it is almost impossible to account for everything, but it's always good practice to at least try our own best. We just take a look at one simple example. Let's say we thought that previous health behavior, which is unmeasured but important factor that may be associated with number of variables that we have here. So we place this unmeasured variable at the reasonable xy coordinates together with the rest of variables and define causal structure. For example, we think that previous health behavior matter to current drinking status, smoking status, physical activity, and also BMI. And we will do the same for the rest part. Plug in the coordinates, label each of the variable, and at the end, we define which one is exposure outcome and also which one is latent variable, which is an unmeasured variable. In this way, we are telling that this variable is unmeasured, so we cannot directly adjust for this variable. Now we get this DAG5 with unmeasured previous health behavior. It is very difficult now to visually assess where are backdoor paths that may be directly or indirectly connected via number of variables due to these unmeasured factors. So we can use the ggdag adjustment set function to identify which variables need to be adjusted to block the open backdoor paths due to this newly added unmeasured previous health behavior. Now this navigates us to adjust for age, BMI, drinking, education, gender, and smoking. And the researchers in the study did the similar way to identify adjustment sets of variable, which is partly different from this slide because we have modified this from the original research for educational purpose, but you may find a similar approach in this cited article. Okay, so finally, since we have touched on a little bit of time scale in terms of adjusting or adding unmeasured previous health status, we will talk a little bit about the situation in longitudinal studies. Our example was cross-sectional survey studies. So the approach and also drawing DAGs were rather simple. But in good epidemiological research, we often have longitudinal study design, and we also want to adjust for not only the baseline variables, but variables that are potentially changing the status over time, which is called time-varying variables. That may apply to exposure, and also that may apply to confounder. And once that happens, it gets very difficult to draw DAGs, but still possible by using time index DAGs. For example, in this case, X is an exposure of our interest and Y is our outcome. And X0 is the exposure at baseline, and C0 is a potential confounder at baseline or prior to the baseline. But since exposure status may change over time, we encode it as X1, which is the status of exposure at the first or second follow-up period. And together with that, confounder or covariates may change the status over time as well. We encode it as C1, and we can connect all these with arrows in a directed way still, so that we can keep the convention of DAGs. Okay. So finally, the take-home messages are that DAGs are very helpful to make our causal assumptions explicit and improve adjustment decisions. It also helps us separate confounders, mediators, and colliders to avoid bias when it comes to adjustment of variables. And it is very important to build our DAGs based on our subjective expertise. And we couldn't cover the DAGs that encode effect modification or interaction, but please refer to the cited article, or we can perhaps do the session about interaction and effect modification using DAGs in the future. And finally, for longitudinal studies, it's good to use time index DAGs. And with that, I would like to end my presentation, and all slides and example codes are available to download from the link. I will send this to all of your email later on as well. And as we have mentioned at the beginning briefly, this is an initiative as Next Gen Health Research Bridge, and we have LinkedIn page, so please follow us on that. And thank you very much for your attention. And now we will take any of your questions or comments.
So far we don't have any questions yet.
Okay. We can start our reflection, Joseph, maybe, or if you have any thoughts or comments on today's session.
Yeah, so thank you so much, Kent. I think this session is quite instrumental for people doing research, no matter whether it is epidemiological or something else. I think it helps us identify the most suitable variables to adjust for in our models. That is, if you are looking at models that you would want to reflect causal models of causal nature. So when I look at this, I think one of the important part is that sometimes you may need to do it stepwise. So which I think what you have well elaborated in your presentation, that is something that I take with me. And there is dual bias that could sort of like affect the DAG itself. I think is something that we need to look out for, especially for unmeasured variables, or even unobservable variables sometimes, endogeneity and the likes. So then the other thing is lastly is the time dependent variables, the ones that change over time, especially for longitudinal studies. Yes, it is something that I would say we need to appreciate more, especially if we're looking at register data. That is becoming very common, in many settings. So I really greatly appreciate your input on that.
Yeah, thank you, Joseph. That's right. It's always good practice. And I just wonder, in your field, health economics and public health, do people use DAGs when they write research articles, or you use perhaps more statistical approach or different approach? I'm just curious.
Yeah, so based on the papers I've read, so there are two sort of like approaches that I've seen people use. So one of them is the DAGs, of course, looking at the relationship between different variables and how they connect to the intervention and or the exposure and then the outcome.
I see.
Yeah.
I see.
So I think that is really relevant, and it is in line with what you have elaborated on today. However, I've also seen people who, first of all, run the models, putting in all the variables, and then they only select those variables that are significant.
Right, right. Of
Yeah,
course, it's very
yes.
common.
Yeah, so then you sort of like question what is the rationale for this. So with that, there could be colliders, there could be mediators that
Yeah,
they are
yeah.
sort of like adjusting for. Although they may be significant in some way, statistically, it may not be good research. The results, the estimate that they get wouldn't be reliable in that regard. So I think it is an area that needs to be emphasized in health economics for people to actually look at the causal links between the different variables under consideration within a given model.
I see, I see. That makes a lot of sense. I now see a very good question actually from the participant. One of the questions is, if DAGs became very complicated, how would you simplify it? Would you recommend to group similar covariates? I found it's very important and relevant question because I have come across such situations a lot. And I totally agree with this, that it is good to group similar covariates. For example, let's say we have the variables age, gender, and then education and income. Perhaps age, gender can be grouped as one, and education and income can be grouped as another, like socioeconomic status and so on. But still, if we have many covariates to account for, it can be quite complicated. So what I would do is to perhaps make several versions of DAGs. If one perhaps larger group of covariates, perhaps we can group it as potential confounders and list all these variables in the same node, and then draw arrow to exposure and outcome and mediators and effect modifier if you have those as research question. And then we can also have another version of DAGs that are dissected into perhaps medium grouping or smaller grouping, and then choose one of those to present or add it as supplementary material in your research paper. Do you have any thoughts on that, Joseph?
Yeah, so maybe in this
Yeah.
particular case,
Yeah.
would you then bundle them at the point when you have included the unmeasured estimates, all unmeasured variables?
Right, right.
Yeah, because my fear is that if you do sort of like aggregate at an earlier stage, you may miss out the nuances in case you add another variable. But I agree with you that bundling could be one of the approaches, yes. But should be done at a later stage.
Yeah, yeah, I totally agree. Okay. Are there any other questions or comments? Yeah, if not, we can perhaps conclude our first session today as Next Gen Health Research Bridge. We really appreciate your participation, and we really look forward to connecting further in the future. So please stay in touch with us. And if you're interested in presenting your work or get engaged in our initiative, you are more than welcome to do so. So please feel free to reach out to us through the email or LinkedIn page. And the next session is planned not specifically yet, but sometime in April from Joseph, right?
Yes, that's
Yes,
correct.
about the health economics, perhaps a bit of methodology or more something about conceptual thing, but it's gonna be for sure exciting. So please stay tuned for that. So thank you very much for participation. Oh, Joseph, did you have anything to add?
No, I don't have
No?
any
No?
additions to make
Okay.
except for thanking you for the presentation that is quite informative and also for the insights that you have shared. Thank you so much.
Okay. Thank you, everyone.